test. Hi, everyone. Thank you for being here. And my name is Asa. I will be the moderator of this panel. I'm the Asia Pacific lead at IONET, and it's great to have this wonderful panel to talk about the future of AI and DePIN. So before we get started, let's just go around and do a quick round of introduction and have everyone know and talk a little bit about your project. How's that?
Hello, my name is Yuan. I'm the co-founder of Gradient Network. So basically, we are an edge compute platform on Solana. So currently, we are focusing on a few use cases, bandwidth related, and also edge AI. So yeah, we'd love to share more details about the project. Great to be here.
Good morning, everyone. I'm Zhi. I'm the global infra head of IoTex. And before IoTex, I working as a research scientist in Facebook for many years. And so IoTex is the decentralized modular infra platform for Internet of Things, building a bridge between real world and blockchain. Our data aggregation platform, DePIN Scan, provide real data for DePIN projects, including the capital caps and the connected devices, as well as the trending news. And it covers 28 billion DePIN ecosystems. So as a leading DePIN infrastructure provider, IoTex enable a new value distribution model by connecting the devices with on-chain and off-chain activity, and also transform the real personal devices into part of the shared economics and tokenize the data from everything. So I will like to share more about IoTex in the following discussion.
Of course, thank you. Niels?
Hey, 大家好. I'm Nils. I work with Aoki. We're a collaborative machine perception platform. This is my colleague, Terry. He's an intern with the Humanoid Resources Department. We help devices like Terry and XR devices have a shared understanding of physical space. It's a DePIN for machine perception. What we help devices do is connect to hyperlocal compute resources and form trustless relationships with each other where they can exchange spatial data and spatial compute resources. We're based here in Hong Kong, and it's nice to be here. Thank you, Asa.
Oh my God, that's so cool. I would love to hear you talk more about how you made that machine possible. Yeah, and Hakan, is that the right pronunciation?
Yeah, Hakan, that's
Hakan.
right.
Okay.
Well, this is the first time I ever got to that close, to an humanoid robot.
He very rarely bites.
Really? Okay. My name is Hakan, coming all the way from Turkey, far from here. This is my fourth time in Hong Kong. Very exciting, as always. Good food, good people, good environment. I think combination of many different cultures. So we're building initwares. Basically, there are three things we're focusing on. The first one is L1, called AnyChain, and then we have cloud services, and then we have SaaS, where where you don't need to actually build an application from scratch. So yeah, those are the three things which I'll get into details later on. Thanks.
Great. Yeah, and let's get into the details. So the first question, I would really love to hear more about the origin story of each of your projects or the ideas you are working on. How do you come to this from what idea, from what background, or what problems are you trying to solve? And yeah, and who wants to? Do you want to go ahead? Yeah, I know you have a lot of experience in DePIN.
Yeah, so basically our main thesis is the compute infra is not going to be static forever, right? So I think 20 years ago, Andreessen Horowitz issued a thesis. So basically it said software is going to eat the world, right? So basically that's pretty much how things work right now, right? So at the same time, when that paradigm shift, the compute infra paradigm also shift, right? So the compute is coming from the on-premises compute to like a fully public cloud infra. So right now, there's another flipping point. AI is, I think AI is eating software. There's another big thesis happening. So I think when that happens, that would also change how compute is organized. So basically, our thesis is a lot of compute is going to the edge, especially when you think about a lot of agentic applications, embodied applications. So yeah, so we're working around to explore different opportunities, trying to build an open platform to aggregate all those resources together. And so we'll be having some very interesting demo showing by the end of this month. Stay tuned. Yeah, thank you.
Oh, wow, that's great. Thank you. And John, do you want to go next?
I'll be the next. So AirText was born out of the desire to bridge the physical world and the digital world in a trustless and verifiable way. So we saw a critical gap between the real-world data from devices and its lack of the credibility and the composability on chain. That current blockchain ecosystem is favor the financial use cases, and it poor at handling the real-world data from devices. So the AirText tried to address this issue by building a DePIN-first blockchain. And in that way, we have the native device identity as IOID on AirText and the data provenance. And now AI layer to contextualize and make use of the data that are produced by the devices. And AirText enable this new way, like the verifiable location, compute, storage, and sensor data for AI, smart cities, and the supply chain at settlers. It also unlocks the DePIN economy with trust minimized coordination between human, machine, and AI agents.
Thank you. I have a follow-up question on that. Yeah, I would really love to, because I think I had a deep discussion with IoTech's team about technical integration. And so can you potentially tell us more about what sort of ecosystem projects are building on the layer one so that like the builders out here can have an idea how can their projects integrate potentially with your layer one?
Oh, yeah. So on our layer one, so it's EVM compatible. So any defined smart contract can be easily running on the layer one of AirText. So in this way, that we can use the any mutual or advanced integration of the EVM compatible smart contracts. And meanwhile, so we have the one that I mentioned, the IOID is the device identity on AirText. So you know, almost all the IoT devices, they have an identity by themselves, but they don't have an identity on chain. So if we can easily have the identity for the devices on chain, which means you can use them to either distribute rewards or have the identity for the data they produced on chain. And meanwhile, we have the off-chain compute middleware called WebStream. And it's based on the ZK proof. So any data that you think is compute heavy or privacy sensitive, we can use the ZK proof to generate a proof and simply verify it on the AirText blockchain. And in this way, so the data computing is more efficient on blockchain. And I think it will be able to adopt more use cases on blockchain as well.
Thank you. Yeah, now I have a much better idea on why or what is like a DePIN first blockchain. Thank you for that. And Niels?
In 2019, I fell very deep into the augmented reality rabbit hole. The mushroom told me that augmented reality was an inevitable part of human language in the future. And I started an augmented reality startup where I wanted to do what I thought would be very simple, overlays for the tabletop game Warhammer. But I didn't know anything about augmented reality when I started this company, so I didn't know how incredibly difficult this would be, because it turns out that physical devices, like my iPhone or Terry over here, don't have a good understanding of the space that they're in, and they certainly don't have a shared sense of the space where you're in. So the problem I ran into very quickly is if I want to leave an AR note on my tabletop game and I want everyone to see the same note, then every device has to have a shared understanding of precisely where they are in relation to each other and that note. And you cannot use the GPS for this. I didn't know that. Because the GPS is a line-of-sight technology. You need to see several satellites for it to be able to work. And even when you have line of sight, you only have a few meters of accuracy. Like Asa, if you checked your phone right now, do you think your GPS knows you're sitting in that chair? Barely knows you're on this floor, right? And I realized that this is going to be a problem for a lot more than augmented reality. This is going to be a problem for the future of robotics. It's going to be a problem for the future of the metaverse, if you believe, like I believe, that the metaverse is going to happen here, not up there. To get two pieces of scale that I think are really meaningful, especially here where we're in Asia. Since GPS is line of sight, it doesn't work very well in big cities with tall buildings, right? New York is the biggest city in the West. It has over 900 buildings taller than 100 meters. But here in Hong Kong, just in Hong Kong, is over 4,000, right? And in the Greater Bay Area, which is, Hong Kong to Guangzhou, technically an area smaller than Greater Los Angeles, are more high-rise buildings than all of North America and all of Europe combined, right? So by the standards of this century, there are no big cities in the Western world. Like all the big cities are in Asia. And the Greater Bay, if you count it as a city, like I do, is the biggest city in the world, already twice the size of Tokyo, on a very comparable area. Another piece of scale that I think is meaningful, I used to live in Beijing for 7 years, and Beijing is another very, very big city. In fact, Beijing is so big that there are more cars on the road in Beijing than there are people in Los Angeles. And the average commute by car in Beijing is around 2 hours. So if you do a quick back of the napkin calculation, you find that roughly the time it took to build the pyramids is lost in Beijing traffic every single week. So around that time, when I lived in Beijing, Naval Ravikant wrote a blog post saying that the internet is missing a fifth protocol that would allow future robots, self-driving cars, AI, things like this, negotiate the use of scarce resources like the road for things like lane merges with each other. This was back in 2014. And he argued that blockchain is going to become this trade layer for the internet. But by 2019, when I was working on this AR thing, I realized, wait, there's a sixth protocol missing too, because these cars won't be able to negotiate lane merges, etc., if they can't talk to each other about space. Like, where are they relative to each other? How fast are they moving? Are we going to have a collision or not? So by 2021, we pivoted away from tabletop games to trying to solve the sixth layer that we think is missing from the internet, a universal spatial computing protocol.
Yeah, thank you. What you said really inspired me because I remember I used to read this book by Yuval Noah Harari, and that beautifully argued where fully autonomous and connected systems are much more efficient than just like individual human brains trying to calculate the local optima. So like if all the cars on the street can talk to each other and optimize on at least a local, like a global scale, that would make our traffic and our roads so much better. And that the same applies to like robotics and every other connected and automated systems. And just on that note, I feel it connects really well back to what Gradient Network is building here, right? Like we
I was
need
just
this
going to say, yeah.
Yeah, well, we need this like little computer on the edge everywhere. We cannot just like all talk to one central NVIDIA or Google cloud server in somewhere in Nevada or something, because that's never the delay. That's never going to work. And of course, excited to hear more about that technology in this conversation. And I think on to you, Hakan.
Sure. I've really literally enjoyed the enjoyed listening to all speakers, in particular, like as a person who had spent 10 years in Beijing, so I can confirm all the info that he just gave. Actually, like many people.
What years?
Actually, all like till last year. I lived in Beijing for 10 years. So
Very nice.
crazy time, and yeah, pollution, but now it's getting much better. More cars than, as you said, the people. I think that was interesting statistics. I didn't know. So basically, our story is. So we know there's a growing tension between data privacy and all this like AI models that we see around. There are so many blockchains around. We know we also get this question: why do you build L1? And we know there are tons of different L1s, L2s are trying to scale in a different way. But what we see is, again, like mostly focusing on data privacy. Like imagine yourself as a person who is at hospital and you're uploading your scans to an AI model, which reveals all the information, including those like confidential, whatever, like private data. So we don't want that to happen. So our focus is actually on privacy, like keeping the balance between transparency, which is one of the core components of blockchain, right? Decentralization and transparency, and how to keep balance between those. Like we want both transparency at the same time. We want partially privacy. You can apply to like enterprises, companies, like RWA, right? Where you want to keep like we know a lot of companies who are launching their own L1. They want transparency to a certain extent. They don't want fully exposed users' information, data, just like banks. So we were inspired by fully homomorphic encryption, which is basically based on encrypted smart contracts, where you don't have to reveal, all the data and information. So this is actually what we currently are building. Thank you.
Wonderful. And just on that note, let's start with you again on the second question around technology, right? Because I think you just mentioned that. So the second question is, what are some of the design choices or trade-offs you have made when designing and thinking about the product experience or the technical experience? Because maybe, for example, with FHE, I have done some of my homework into it, and I feel one of the challenges with FHE is that it's very computationally expensive. So it takes a lot of overhead to just calculate 1 + 1 = 2 or 1 + 1 = 2 in the FHE way. So I wonder, how do you think about maybe the design choice around that, or just around any number of other things when you are thinking about the chain and how it's like uniquely positioned?
And another actually question is being asked is about like your question and plus decentralization. And that's also one of the questions that has been discussed previously in the previous panel. I was here, had the chance to listen, and I want to touch upon the decentralization part here in particular, which is also like very core component of blockchain technology. So there are trade-offs, but we know this, like there are thousands of DAOs, so-called like decentralized autonomous organization. They call themselves DAOs. In particular, like I'm not sure, like you as a person in Beijing who lived in Beijing, if you're in the crypto space for a long time, you had one time, like I think 2-3 years back from now, literally every community had formed their own DAOs. They said we're DAO, but they without knowing actually what DAO is, what DAO means. So where's decentralization here? Where's transparency here? Like how do you make this decision-making process, how do you what, blah, blah, blah. So, and basically you can apply the same thing to, everything in blockchain, like including L1, L2s, whatever application you're using. So there is no, like, I would say 100% decentralization no matter what. So if a person saying so, I think, I don't believe. So to a certain extent, you need to have humans, you cannot make it at the cost of or sacrificing from user experience, whatever interfaces that facilitates user or Web3 adoption, whatever. So we need to have human beings there. So we're using this algorithm and also mechanism called fully homomorphic encryption. Yes, it actually consumes a lot of data, and we have the same issues with ZK, right? Zero knowledge proof, so much computational power you consume. And then we actually have DDA, which actually adjusts this blocks to in a way that some part of you can use CPU. Currently, we are at this stage, actually very early stage. You can use like general purpose, devices, CPU-based devices, where you can, be part of the ecosystem of blockchain. And at the same time, we're proceeding to now GPU and then Isaac, which is most advanced. And later on, we're going to be consuming a lot of, we will need actually, that requires, if you want this privacy-based, encrypted smart contract and etc., it consumes a lot of computational power. So that's why, it's just a stage that we're proceeding to. Probably it will take a while. Yeah, thank you.
Thank you for the walkthrough. And Niels, I see you want to jump in. Go for it.
I was just going to say that I've learned that a DAO is any organization that votes to give itself the treasury, right?
Probably. Particularly in Asia, probably, yeah.
I think for robotics and physical AI, there are some very painful trade-offs that you have to make because latency is more important for XR and robotics than really for any mainstream internet use case so far. I used to be a competitive gamer, and if I had a ping time of 20 milliseconds, I'd be pretty satisfied. You can play well on 20 milliseconds, but 20 milliseconds is dangerously high latency if you're doing collaborative spatial computing, because a lot of stuff happens in the real world in 20 milliseconds. If you're teleoperating a robot, meaning that you're controlling a robot remotely, and you have 20 millisecond latency to that robot, that means that you've more than doubled your reaction time. So if you're moving your heavy robotic arm around and someone steps in front of you, you're not going to be able to react on that on time. And if we have cars that are trying to coordinate with each other and they are not talking to each other with low latency, they're going to crash. So physical AI, robotics, XR, these things need lower latency than really anything on the internet so far. And that also means that you don't have the luxury, in my opinion, for things like robotics and XR to play with these amazing new technologies like CK and FHE, because there's no time. And so how do you tackle privacy in such a real-time environment? And to kind of set the stage for this, I need to tell you guys a little bit about how are people solving the problem of positioning without GPS? What are people doing? And it turns out that all the major tech companies, Tesla, Apple, Google, Microsoft, literally all of them have embraced this approach called visual positioning. They may call it something else, spatial anchors, something like this, but really what it is you compare what you are looking at to a 3D model of the world. And anytime you do a computational comparison, both those data sets have to be in the same place. So that means either I'm going to send my whole world model down to your XR glasses, which is not practical, that's not going to happen, or I'm going to ask you to send the camera feed of your glasses to me, and that is 100% of the time what happens. And when I realized this back when I was working more in XR, this made me very, very nervous about the future of humanity, because if you believe, like I believe, that within a couple of years, a lot of us are going to be wearing AR glasses, that's maybe the biggest privacy threat that humanity has faced so far. Mark Zuckerberg has been able to know what we post on the internet for a long time, but Elon is going to be able to know what your wife keeps in her bedroom drawer because there's a robot in your home. And that's no joke. Like just a couple of months ago, Elon was on Lex Friedman's podcast and said that his humanoid robot Optimus is going to be the greatest source of data in the world. It's going to be the greatest source of data in the world. So it's 100% his plan to spy on us in our homes when we buy these robots, right? He's not even embarrassed about it. He's happy to share it on a podcast. So those are two very big problems for robotics and XR, latency and privacy. And the way we chose to tackle this was to decentralize the visual positioning stack. So what does that mean? Well, we've embraced polycentric decentralization, meaning essentially we want to reduce the privacy impact to the privacy that's already been lost today. And to do that, we make it a relationship just between the visitor and the venue. So when you visit the mall and your future AR glasses connects to the VPS system of the mall, then the mall might know what you're looking at. But they already know because they have CCTV cameras on you. But I won't know, and Mark won't know, and Elon won't know. So you decentralize the visual positioning stack by allowing the visual positioning system to be a network of venues that serve maps instead of building one big map of the world. And I think this is very important because even the other Web3 visual positioning systems that are being built, because we are not the only VPS in Web3, there's also the amazing guys at OVR and at MeshMap. They are still choosing as a business model to be the central repository where this world model gets built. So Niantic, the makers of Pokemon Go, they made a huge world model by spying on us when we play Pokemon Go. But they still had decentralized data collection. You know, they collected data from us. And now Web3 is doing the same thing, but they're giving us token rewards. But that doesn't change that all of this data is ending up with OVR or with MeshMap. So the way we wanted to tackle this at Aukey is a commitment to we are going to have none of the data. Literally none of the data is going to be with us. We're going to make this decentralized in the way that each venue is responsible for running their own visual positioning system.
Yeah, of course. And you see all the big tech talk about like they don't have enough data to train their AI models. You know, that's what's going to happen if we leave our data to the big tech. Yeah, John, do you want to go next?
So in crypto, or maybe all the industries, we always request higher throughput, shortened response time, and less cost. And so in essence, the problem is whether the technical capacity can meet the growing demands. Like making a trade-off is one of the ways to address this problem. And for AirTags, like in 2018, when we first start building this blockchain, we observed that both BTC and Ethereum has the problem in their consensus mechanism that they need a large portion of their nodes to participate in the consensus process, which result in inefficiency and significant waste of computing resources. At that time, we trade off the consensus a little bit with a new proposed consensus protocol called the delegated low depose. So in that way, the AirTags blockchain consensus can run very fast, and it's still decentralized and flexible to optimize the speed and scale. Of course, it's a trade-off between the efficiency and decentralization. But from an engineer's perspective, so I do believe that the technological progress is the key to solving the technological challenges. And so the best way to resolve the problem is to keep exploring and adopting new techniques. Like the ZK proof, the zero knowledge proof is an excellent example for that. As I mentioned previously, for our off-chain, the computing middleware, we use the ZK proof to do the complex off-chain computing. And so for on-chain, we just need a very simple, relatively simple verification on-chain. And in this way, we expand the use case of our blockchain. And this is the way that I say no trade-off by using the technique to resolve the problem. And returning to the consensus issue, so at that time I also new to the blockchain technique. So and gradually we learn more and more. And in the third quarter, Altex will further reduce the block time to 1 second without sacrificing any decentralization. So we improve the efficiency, but without sacrificing the decentralization, which is opposite of what we did in 2018. And I think that so all these cases prove that technique is the the key to resolve these issues relies in technique.
Yeah, thank you. I loved how your position of this like technical optimist, because like the throughput, the processing power, and everything about the hardware we have is constantly improving. So that's of course gonna drive the quality of the service and the quality of the blockchain better over time, right? Yeah, and finally, and I really cannot wait for Yan to tell us more about edge networks, because I think we have talked so much about it already.
Sorry, the question is about like how we design the protocol?
Yeah, or
okay.
like product design decisions or any trade-offs you have faced or any challenges you are solving.
Sure. So basically, I want to talk about like the very grand architecture of our system. So basically, when we are trying to deliver edge compute from a client to a customer, I think at the bottom part, it has to be a very strong peer-to-peer networking, right? So if you are delivering some compute results from one party to another party, if I go through a relayer, so that creates a lot of latency, a lot of data traffic, and also create privacy issue. So at the bottom, it has to be peer-to-peer. So I think in the past several months, we have been working very hard to do actually a global experiment. So the product is called Sentry Node. Basically, we'll create this browser plugin. Everyone can just download in like a second, and people can two arbitrary nodes in the world can connect with each other. Basically, that's what they do, and we record all the latency, all the NAT status, and all the network-related characteristics. So I think that's a very big part of what we're trying to do in the future. Because if you don't have a very strong peer-to-peer connection network at the bottom, then you cannot deliver. So that's at the bottom. And so our second layer is a resource aggregation layer, right? So software-defined network is very powerful right now. So I think in the past, when you talk about cloud, it's most likely homogenized or semi-homogenized. But right now, our software is so capable that we can control different kind of heterogeneous compute resources, aggregate them, virtualize them, and commoditize them to a single unified layer. So I think in our vision, that's the second layer. And the third layer is an orchestration layer. Because there are so many different use cases, it's very hard for developer to understand the whole stack and to build upon it. So what we're trying to do is we want to build middlewares and some use cases to showcase the developers, okay, you can very easily tap into this resource pool and trying to build your applications. So I think in the traditional DePIN network, most likely you are building your own supply side and demand side. But I think our vision is you don't have to rebuild the wheel again by yourself. There's a huge pool of compute resources you can tap into very easily. In terms of design choices, we want to keep it as modular, as practical as possible. Because I'm a big believer of technical optimism. So some of the problem like ZK proofs, FHE, right now it seems very difficult. But I think in a couple of years, iterations, things will become much more economically viable. So yeah, that's my idea on it.
Yeah, thank you for that. And of course, I feel one of the most exciting promise of DePIN is that we are able to create this unified single interface to make use of these otherwise heterogeneous resources from all across the world. And yeah, and we spend a lot of time talking about this very exciting technical stuff. We are running a little bit short on time, so let's skip to the final quick fire question. That is, what's the most exciting thing that happened to you personally or to your project in 24? And what are you looking for or looking forward to in 425? What can our community, our audience, or people who are looking at our projects expect or be excited about in the coming year?
I can start for this one.
Go ahead.
So in 2024, we launched the IoTeX 2.0, and which is introducing a modular infra and enhancing the support for DePIN projects and setting a stage for DePIN and AI convergence. So our ecosystem expanded to over 200 projects, including 50 DePIN initiatives, which solidifying the IoTeX position as the leading DePIN ecosystem. We also rolled out the IOID, which I mentioned previously, for the on-chain device identity and web stream for verifiable real data integration. And for community engagement, we successfully host the real-world serial, and which is for the collaboration among the developers of DePIN and AI. And for 2025 and beyond, I think we will be focusing on merging the DePIN and AI, and to enable the physical AI and sensual agents, allowing AI systems to interact with the real-world data. And last month, we launched the Quicksilver, which is an open source platform for combining large language model with DePIN data to facilitating the advanced AI applications. And we will continue the US market expansion, strengthen the presence in the US through partnership with institutions and platform. So IoTeX is the chair of the DePIN work group in the US Blockchain Association. So we will continue to work with the other AI companies or the tech lead to advance the and drive the innovation and modernize the infrastructure through DePIN solutions.
Thank you. And
Working in AI and robotics, it's easy to worry about, am I the bad guy helping build things that will take our jobs tomorrow? So one of the things that was a personal highlight for me last year was seeing how using spatial AI, making the physical world accessible to AI could help make the physical world more accessible to people with disabilities. Two things that we managed to accomplish last year was helping blind people navigate a physical space. We helped, for example, one blind person navigate to the bathroom for the first time just on his own using a phone, which was a goosebumps moment for me, but also helped cognitively impaired workers in a retail environment, according to their colleagues, start operating at the same level as their peers. And I think that's one of the biggest promises of spatial AI in particular, is that we can start helping people in the physical world do better. And that was a big highlight for me.
thank you. That's really sweet. Okay.
Yeah, last year, I mean, if it's a private question, and I will answer in that way. So the most exciting thing happened to me was to meet a lady that I will marry in a month.
Wow.
That was the most exciting one for me. But when it comes to getting back to the product, we completed testnet successfully, had thousands of smart contracts deployed, hundreds of thousands of transactions completed successfully. That was important for us. And in the past, basically, we were refraining from participate in such events. I mean, having booth and organizing so many events because the product was not ready. But from this year on, we're going to be very active, getting in touch with the ecosystem leaders so that they can come and build with us. We learn from one another. That's what we think and believe. Thank you.
That's great to hear.
So I think we're still a very young project. We actually just launched last September during the breakpoint. So the thing probably I'm most excited about is in the past 5 months, so we have seen tremendous growth in our network. Right now we're running around like 3 million concurrent users as I speak right now. So that's it's very rewarding, but also creates a very challenging position for our infra team to keep that scale open. And I think next month we will be releasing 2 very, very exciting demos. I'm very proud of. So yeah, that's another exciting part this year. Yeah. Thank you.
And so everyone, please be on the watch out for new releases coming out of Gradient. And thank you everyone for having this wonderful discussion.
Thank you.